Okay, so I hope those concepts are clear to you now. Okay, now we're going to move on with our next topic. So it says magnetic field. So I've already used the word magnetic field and I told you that the area around the magnet in which it exerts its power of magnetism, basically, or the area around the magnet where you can feel the effect of a magnet. Like I said, if I'm standing with my hands out and rotating, so that area that my hands can cover is my field, or if I'm a magnet, it's my magnetic field. So let's see how your PPT defines it. Okay, then we'll try to understand it. So it says that the region surrounding a magnet, which means a region around a magnet in which the force of the magnet can be detected is said to be a magnetic field. So right now, just let this picture be. This would make sense a little after some time, but if this is your magnet, this is your bar magnet, this is your north pole and this is your south pole. So if, say, this region, I'm just showing you a dotted line for denoting that this is the region in which the force of the magnet. So your PPT says that the force of the magnet. What does it mean? Why are we using the word force? We know that when two magnets are brought together that are the same pole, so they repel each other, obviously. So when something is repelling, that two magnets are repelling each other, there is some force involved, right? Otherwise, how would you feel that repel? If you try to bring the same poles of the magnet together, you will feel that they are pushing each other away. You will feel that force. And similarly, when you bring opposite poles closer to each other, you will feel that force of attraction. So there is force involved in the magnetic field. So there is some force that that magnet carries. Okay. So that area in which the force of the magnet can be detected, that means in which the magnet can actually exert its power of magnetism, or you can say in the area around the magnet, you can also define it in this way: the area around the magnet where its influence can be detected is the magnetic field, or the area around the magnet where you can actually feel the effect of the magnet is known as the magnetic field. Okay. Now let's move on and make this a little more clear to you. So how these magnetic fields are, how they're told to you what is their direction, and how do you tell where they are stronger and where they are weaker is through these magnetic field lines. Okay. Now, the magnetic field is a quantity that has both direction and magnitude. Do you know what these quantities are called? The quantities which have both direction and magnitude, they are known as vector quantities. Okay, this is something that if you have studied about or you know about, well and good, or if you haven't, don't worry about it. This is just some additional information for you. So vector quantity basically means it has both direction and magnitude. What does that mean? It means that if you take say area of a square, so you have this square and it has a side of 4 centimeters. Now you say, what is the area of this square? It is, so 4 centimeters is 16 centimeters square. So this 16 is the magnitude or the quantity, actually. This is the unit. But does it have a direction? Does this area actually have a direction, the area of a square? No, right? So when we specify it like this, it is a scalar quantity. That means it only has a value, or it only has a magnitude, but it doesn't have any direction. Area is not in this direction or in this direction. It's just there in one place. But the magnetic field lines have both direction and magnitude. How do they have direction? In this way. This second picture shows you how. It is, let's read in your PPT the next line, that it is taken by convention that the field lines emerge from the North Pole and merge at the South Pole. What does that mean? This is your bar magnet. I'm simply going to use the language that your PPT is using. It says that it is convention. Convention means it is just something that is taken as it is, and it is a widely accepted concept or a widely accepted way of dealing with it. So by convention, we say, okay, so now that you know about magnetic field lines and their properties, we can get to the actual thing that we need to study in this chapter, that is the magnetic field due to a current carrying wire. So now you remember when I told you how Hans Christian Oersted discovered that when you keep a compass needle near a current carrying wire, it gets deflected. So that's how we knew, okay, so somehow electricity or the current that is flowing through that wire is related to magnetic field. It is somehow giving rise to a magnetic field, or it is acting like a magnet, right? It is not exactly a bar magnet. Is the current carrying wire equal to a bar magnet? No, they are completely different things. But he definitely got to know that there is some magnetic field. Even though there is no specific magnet per se, there is some kind of magnetic field being generated around that current carrying wire. So in the next chapter, in the next class, that is what we're going to start talking about. So make sure that the properties of magnetic field lines, magnetic field, and about a magnet are completely clear to you, so that you don't get confused in the coming topics. Okay, I hope you enjoyed studying this, children. Thank you and take care.